Okay, so this is a practical example of what we just did, what we just studied under the critical path method. This is a practical example that you may have in your examination whatsoever. And so, very quickly, I will try as much as possible and go through all of these questions very quickly, and then we can finish up and go away. So when the question is given like this, it's saying activities, predecessors, and duration. Now activity A has no predecessor. Of course, we understand that because that is the start point or the starting activity of the whole project. Activity B has A as the predecessor, and their duration is given in weeks, and so they are all here. Now these are the various questions. The questions is saying that we should find the slack time of activity A. And so what is the slack time of activity A? We are finding the critical path of the whole project. And so for the whole project, what is the critical path of the project? And then we are also finding the early start time for D, for activity D. And then we are also asked to find the late finish time for activity G, sorry. So very quickly, first of all, we have to get our network diagram drawn. And so activity A, we have activity A here. Our board is not enough. We don't have enough space. And so once I'm done with this one, I clean and then I proceed. So we have our activity A, which has 6 weeks. Then we go to activity B, whose predecessor is activity A. And so we quickly, activity B, that is also 5 weeks. Then we have activity C, whose predecessor is activity B. And so we go to C with 4 weeks. Then we go to D, whose predecessor is activity A. And so all the way from A, we have D. We have activity D that is giving us 6. And then we have activity E, whose predecessor is D and C. So we have activity E here. We have activity E. That is 3 weeks, finishing in 3 weeks. Then we have activity F, whose predecessor is C. And so F is here. F is giving us 5 weeks. And then we have activity G, whose predecessor is E and F, and completing in 2 weeks. So activity G in 2 weeks. And so this is our first diagram. This is our very first diagram. This is the first thing we have to do. And then once you get your network diagram right, it means you are on the right path. And remember, we used the general rule. Do not forget, we are going to use the general rule to draw our next diagram. And then if you are quickly enough, you can even draw the next diagram. I should have, if there is enough space, I would have bolded the notes or the boxes such that we'll be able to get the other figures in there. But because we don't have enough space, let me just clean it quickly, and then we start with the rules. So we have our rule here. Our rule, we have 6 boxes. We have our activity here. We have the duration here. Then remember, we have the earliest start time here. Then we have our LS here, that's the latest start time or the late start time, the early start time, the late start time, the early finish time, and the late finish time. So this is our general rule. We are going to apply this in our next diagram such that we'll be able to get all these answers in our next diagram. Very easy. And so we come to activity A, 1, 2, 3, 4. Okay, let me just, for the purposes of space, Just bring it here. 1, 2, 3. Then we have our fourth. We have A, and A's duration is 6. Right there. Then we have B in here. So we have activity B with how many weeks? 5 weeks. Then we have activity C, whose predecessor is B, and so we go ahead with C. 1, 2, 3, 4. So we have C here, and then C has 4. Then we go to D from A. So D from A. We have D here, and D is 6 weeks. Then we go to E from C and D. So from C and D, we go to E. So 1, 2, 3, 4. Nicely. We go to activity E, and activity E has how many weeks? 3 weeks. And then we have our activity F with a predecessor C. So we'll draw our F here nicely. 1, 2, 3, 4. F with how many weeks? 5 weeks. Then we have our G connecting both the F and then the E. G with 2 weeks. Now, remember A is our starting activity, and so it will always have 0 early start time. It will have 0 early start time because that's the starting activity. And then remember, our forward pass is ES plus D, which is going to give us our EF. And so 0 plus 6 is 6, very easy. Then from A we go to B. You know, A is the predecessor of B, and so A's earliest finish time becomes B's early start time. And so we have our 6 here. 6 plus this is 11. I'll be moving very quickly now. And so we have 11 here. 11 plus 4, we have 15. And then A is still connecting to D. And so we have our 6 here. 6 plus 6, we are going to get 12 here. Now we have activity C and activity D connecting to being predecessors for activity E. And remember, we are taking the biggest or the big value or the highest value. And so 15 and 12, the highest value is 15. So we take 15 here. 15 plus 3 is 18. Now C is also connecting, or C is also the predecessor alone for activity F. And so we bring the 15 here. 15 plus 5 is giving us 20. Very nicely. Then we have activity F and E connecting to J. And we are still using the highest value. And so 18 and 20, we would have to use 20. And so we have our 20 here. 20 plus 2 is 22. Remember in the previous video I told you that the early finish time must be the same as the late finish time, because whatever be the case, that is the finishing time. And so 22, we bring 22 down. Now 22 minus 2 becomes 20, because backward pass we are subtracting, forward pass we are adding. Now we have 20 here. So you bring 20 here too as well. 20 minus 5 is 15. You bring 20 here. 20 minus 3 is 17. Now we have 17 here and we have 15 here. Mind you, when we are going forward, we pick the highest value. But when we are coming back, we pick the smallest value. And that is because both F and E are connected to C. C is the predecessor of both F or E and F. And so since two activities are connecting to one, we take the smallest value of the predecessors to the late finish time, and so we have 15 here. 15 minus 4 is 11. We have 17 here. Mind you, E is only connected to D, right? E has the predecessor of D, and then C as well. And so you bring your 17 here. 17 minus 6 is what? 11. So you have your 11 here, because B is only connected to C. And so 11, you bring your 11 here. 11 minus 5, you have 6. You bring your 6 here. 6 minus 6, you have your 0. So this is nicely done. So we get on with our questions, because the diagram is nicely drawn, and then the values are there, as you can see. Yes, so that is 22 over there. Now we take our first question. The first question is saying that we should find the slack time of A, and I indicated earlier that the slack is equal to either LS minus ES, so LS minus ES, or LF minus EF. So this is the formula for slack. For the rule, applying the rule here, this is LS, this is ES, so this minus this is 0, and this minus this is 0. And so our question that is asking us to find the slack time of A, the slack time of A is equal to 0. The slack time of A is equal to 0. Now to the second question. The second question is asking us to find the critical path. And in the previous videos, I told you that critical paths are the paths that has the 0 slacks. And so all the activities with 0 slack, you draw your line through to find a path through them. So we have our critical path. So A is a critical activity. A is not critical path. B here, 11 minus 11, 0. 6 minus 6 is 0. When you come here, 15 minus 15 is 0. 11 minus 11 is 0. Then you come to activity F. 20 minus 20 is 0. 15 minus 15 is 0. You come to activity D. 17 minus 12 is 5. And then 11 minus 6 is what? 5. You come to E, activity E. 20 minus 18 is 2. 17 minus 15 is 2. Then you come to G, which is the last activity. 22 minus 22 is 0, and 20 minus 20 is 0. And so these are our activities that are our slack activities. All the activities with 0 on them means they are our slack activities. But then before they become slack path, then you have to join them. And so A, therefore our slack path is equal to A, activity A, activity B, activity C, activity F, and activity G. This is our slack path, or this is the critical path. And then the critical path are the activities, or are the path that has 0 slack on all the activities. And so we have a number of paths. So first of all, let's find out the number of paths we have here. Then we find our slack path. So, or the critical path. So we have A. From A we can come to B. From B we go to C. From C we go to F. And then F we go to G. That is path number 1. Path number 2, we start from A, then we go to B, then we can still come to C, then we come down to E, because remember C is connecting to E, and then we go to G. Then we have our third path being A, connecting to D, and then we come to E, then we go to G. So these are the various paths of our project, and the question is asking us that what is the critical path? And I am saying that for these 3 paths, the one that has 0 slacks of all the activities, or the one that each of the activity has their slack 0, that path becomes the critical path. And from the diagram, we know that from A, B, B to C, C to F, and F to G, which is A, B, C, F, and G, all have 0 slacks. And so all the activities with 0 slacks then becomes critical activities. And putting them together this way becomes a critical path. And so we are done solving the question number 2. Let's move on to the next question, which is asking us to find the early start time for D. The early start time for D. The early start time for D. Now, where is activity D? This is activity D. So, just looking at your rule, this is the early start time. And so if we are looking for the early start time for activity D, it is nowhere but this 6. The 6 becomes, so look at where the 6 is and look at where the early start time of the rule is. And so the early start time of activity D is 6 weeks. Nicely. Then the next question is asking us to find the late finish time for activity G. Now, still come back to our rule. The late finish time is located at the right side below the early finish time. And so when you go to the box or the note of activity G, this is the note of activity G, you can see that the late finish time for activity D is also 22 weeks. And so we are asked to find the forward pass, or the duration for the entire activity, the forward pass of the entire project, or the duration for the entire project. Then it becomes the earliest finish, or the early finish time, or the late finish time of the last activity. So the EF or the LF of the last activity is the entire duration for the whole project, or the entire project. And that is the forward pass of the project. Now the backward pass is the early start time or the late start time of the first activity, which is activity A. And so this one becomes the early start time of the entire project. And this becomes the duration of the entire project, or the late finish time of the entire project. So this has become very simple. We are now solving the practical example, and then so wherever you find yourself and you come across such an illustration, I pray and believe that you'll be able to get it done in peace.